Welcome to Edifo. Today we are going to learn how to conduct a one-sample t-test with Microsoft Excel and how to report the results of the test in API format. T-test is one of the very commonly used parametric tests. I have already uploaded a video of one-sample t-test using SPSS. In that video, I have already explained the theoretical background of the t-test, that is assumptions, data types used in t-test, etc. in detail. I request you to please watch that video for detailed theoretical background of one sample t-test. Please visit the link in the description below of that video. The one-sample t-test is used to compare the mean score of our sample with the population mean. That is, one-sample t-test determines whether a sample comes from a population with a specific mean. Here, the sample mean is the observed average and the population mean is the expected average. Using one-sample t-test, we compare means, that is, compare sample mean with the population mean. A one-sample t-test allows us to test whether a sample mean significantly differs from a hypothesized value, that is, the population mean. The population mean is not always known but is sometimes hypothesized. Here is our research question. A company wants to improve the sale of their product. For that purpose, they plan to conduct an online advertising campaign for the promotion of the product. They assess the average sales per day for the product before the advertisement campaign was $5,230. They collected a sample of 150 days of sales figure after the implementation of the advertising campaign. We need to check whether any significant difference in mean between sales figures before the advertising campaign and after the advertising campaign. Here we have a known mean, or we can say the hypothesized mean, that is $5,250. We are going to compare this mean with the sample mean to check whether there is any significant difference between these two means. Next, we move to the hypothesis. So this is the null hypothesis. There is no significant difference between population mean and sample mean. Here, there is no difference between average sales figure before and after the advertisement campaign. Before the advertisement campaign, we are considered as the population mean or hypothesized mean, and after the advertisement campaign, we are going to calculate. And this is the alternative hypothesis. There is a significant difference between population mean and sample mean. That means there is a significant difference between average sales figure before and after the advertisement campaign. That is, the figure before the advertisement campaign and after the advertisement campaign, we can see a difference. So now we are going to test the hypothesis using Excel. Let's move to Excel. Open your Excel. Here I have with the sales data. These are the daily sales data for the last 150 days. You can see here. And we are going to apply the one sample t-test. Here I am going to demonstrate two methods for calculating one sample t-test. Let's move to the first method. Just move to the data menu, and here you can see a data analysis icon. You can see different hypothesis testing methods here. If you can't see this menu here, you can enable this by clicking on File menu and select this Option button and Move to add-ins menu, click this analysis tool pack and press here go button. Here you can see 4 items. Select the first item, that is analysis tool pack, and click OK. Now I am going to select this data analysis menu. Click here. Our option is this ttest to sample assuming unequal variances. You can see here this is a 2 sample t-test, but we are going to conduct a 1 sample t-test. For solving this, we need to make some adjustments in this data sheet. For that, cancel this menu, type here dummy data, give 30. Now we have 2 sets of data, then we can conduct the 2 sample t-test. This row is considered as, this column is considered as dummy data for the 2 sample. Now we are going to conduct 2 sample t-test. Data analysis, t-test 2 sample assuming unequal variances. Click OK. The first variable range, this will be the first variable range, that is the sales values for 150 days. Select the entire range. Now it's demanding the second variable, that is our dummy data. Select these 4 rows. Now the third is very important, that is the hypothesized mean difference. That is hypothesized mean. Our hypothesized mean is the sales average before conducting the advertisement campaign. Okay, that is 5230, 5230. That is our hypothesized mean. Then sample mean that we are going to calculate using this procedure. Now the label, you need to check this label because the first row is considered as label, that is sales, and dummy is considered as the label for the data, and that column is not considered as the part of the data. That's why we are check this label, and our alpha level is 0.05. That is the level of significance. Normally it is 0.05. Almost all these social data analysis we are considered 0.05 is our level of significance. And the last data that we need to set, that is output range, where you want to display this output of this test. Now I am going to select H2. This column is considered as our output range. So this much enough. First variable, second variable, we are going to conduct a 1 sample. So second variable is considered as dummy here. And you have to specify the hypothesized mean and the level of significance and output range. Enough. Click OK. We can see the double click. We can see this data. This is the dummy data. I'm going to delete it. Now the data is ready. Now click here. Is it 2 sample? No, it is 1 sample. 1 sample. Delete it. And hypothesized mean difference. No, this is a hypothesized mean. Okay. DF means degree of freedom. Enough. Now I am going to explain this. The p-value here displaying it's in exponential format. So right button, click here and select this format cell and convert this into number. Now it's okay. The same way we need to change this value. Format cell, convert this into number. Now the p-value 0.00. If you change this, select this home, then you can see this is 0 itself. No problem. Now we have with the result. Now I am going to copy this and paste it into the PowerPoint slide. Thereafter I will explain in detail. Okay. Now check this table. This is a table I have copied from the Excel sheet. You can see very important things are there. The mean value, the average sales figure after conducting the advertisement campaign. That is, this is our sample mean. Then variance. This is a variance. And this is observation 150 sample because we consider the sales of 150 days after the advertisement campaign. And this is the hypothesized mean. That is a mean before conducting the advertisement campaign. So we have, this is a sample mean and this is a hypothesized mean. And this is the degree of freedom, that is 150 minus 1, that is 149. And this is the t statistic. This is the t value. And this is a p value, probability value. If you are conducting one tail test, this is the probability value, p value. This p value is very important because in research, for testing the hypothesis, we are following p value method. And this is the t critical value of one tail. We are conducting a two tail test. So we are taking this p value two tail and t critical value two tail. These two values very important. Now, the first method, that is a p-value method. In p-value method, if the p-value less than alpha, that is 0.05, then reject the null hypothesis. Else, fails to reject the null hypothesis. Check. Our alpha is 0.05 and our p-value here, the p-value two-tail is 0.00. Get it? Here, p-value 0 is less than 0.05, so reject the null hypothesis. So if you are considering the p-value method, we are reject our null hypothesis. The null hypothesis is there is no significant difference between hypothesized and sample. So we reject that. That means there is a significant difference between the hypothesized mean and sample mean. Okay, you can see here. 5230 and 5871. Definitely there is a significant difference. So according to p-value, our conclusion is that we reject the null hypothesis. So there is a difference between the hypothesized mean and sample mean. This way. Correct? The next method is the critical value method. We are also going to check this whether our null hypothesis is true or whether we are going to reject the null hypothesis using critical value method. So in critical value, we are considering a normal distribution, suppose, and this is a rejection region. These are the rejection region because we are above and below the t critical value is considered as a rejection region. So this is a t critical value 1.976 here minus 1.976. So 1.976 is the critical value, t critical value. And the rule is that where our t statistical value reside, it is this region because this point is 1.976. Then 23.177 should be in the rejection region. You can see here. Here it is in the rejection region. So we can conclude that if the t statistic is greater than the t critical value, we will reject the null hypothesis. Get it? Now we can conclude that if the t statistical value is greater than the t critical value, then reject the null hypothesis. Here you can see the t statistical value is in the rejection region because it is greater than the t critical value. Get it? So this way we can conclude again our null hypothesis is rejected because we are going to approve the alternative hypothesis. The alternative hypothesis is that there is a significant difference between the hypothesized mean and sample mean. This is the two methods we can apply for testing the hypothesis. Here we are going to adopt this method because the p-value method is widely accepted method for research purpose and PhD theses. So you can follow the p-value method. This is an alternative method. Okay. Now we are going to the second method. In the first method, we had applied this data analysis option. Instead of that, Excel has equipped with a lot of mathematical functions. Now we are going to calculate all these parameters using Excel function. So for calculating this, we need some parameters. First of all, we need mean value. The second one, we need standard deviation for calculating the variance. Next, we need the number of observations. So we need the count. The next one is the standard error of mean. standard error of mean. Next one is the degree of freedom. DF. Next one is the hypothesized mean. The next one is the T statistic. Next one is the p-value. Now we are going to calculate all these parameters using the excellent Excel functions. Now we are going to calculate one by one using the Excel inbuilt functions. Before that, here I am going to copy the previous result. Here I am going to copy it. So this is the result that we have already calculated using the inbuilt facility of Excel. Here I am going to change this into format cell, number. Okay. Now check whether the result is going to become the same as the previous one. Now we are going to calculate the mean value. This is the mean value. So here equal, just apply the function average. Select this sample data range, full range. Then close the bracket, press enter. We can see the result is same. Get it? Now we need the standard deviation because we need to calculate the variance. For that, we need to calculate the standard deviation. For that, apply a function equal to std, standard deviation sample.s. This is population, this is sample. stdev.s, apply, then select the same range, then close the bracket. This is the standard deviation. If you square off this, you will get this variance. Okay. Now we need to apply the count, how many observations that we have. Definitely you know this is 150, even though we can find it out through an Excel function equal to, we can apply count function, select the full range, then close the bracket, 150. Okay. Then standard error of mean, we need to find it out. Standard error of mean. Now we are going to calculate the standard error of mean. Standard error of mean, SEM, commonly known as SEM. It is the standard deviation of the sampling distribution. Its equation is a standard deviation divided by the square root of observation. Okay. So equal to standard deviation divided by square root of the count. SQRT, square root of 150. This is the standard error of mean. So this is a standard error of mean, that is 27.689, the standard error of mean. Now we are going to calculate the degree of freedom. Normally you know degree of freedom is the number of observation minus 1, because we are applying one sample. So equal to 150 minus 1, that is 149. Here also we can see 149. Now hypothesized mean, this is equal to 5230 is the hypothesized mean. We can type 5230. Okay. Now we are going to calculate the T statistic. Now check what is the equation for calculating T statistics in statistics. This is the equation for T statistic. That is x bar. X bar is the mean value. Okay. Mean value of the sample minus the population sample mu. That is hypothesized mean. That is 5230 divided by standard error of mean. This is the standard error of mean. That is 27.689. So all parameters are there. Now we are going to calculate the T statistic using this equation. Now click here, equal, start a bracket. This is the sample mean we have already calculated here, minus this is the hypothesized mean, that is 5230, then close the bracket, divided by standard error of mean. This is the standard error of mean. Everything is okay. Then press enter. 23.1772. That is the T statistics. Check here. 27.1772. The same T statistic. Okay. Now we are going to calculate the p-value. For that, we are going to apply an inbuilt function of Excel, that is ttest. T-D-I-S-T. T distribution. First parameter is the T statistic. X represents the T statistic. Select this column, comma. Next one is the degree of freedom. We have already calculated the degree of freedom, that is 149. Then comma, one tail or two tail. We are applying two tail test because we are checking the significant difference. If you are checking whether the sample is greater or less, you can apply one tail. Here our research problem is whether there is a significant difference or not. Difference will be greater or less. So we are going to apply two tail. For that, type 2. Then close the bracket. Then press enter key. Now change the format to numbers. Right button. Then select format cell. Convert into numbers 0.00. That is a two-tail p-value 0.00. So this way you can calculate all the parameters that we have had with this inbuilt facility of Excel. You can apply equations for calculating all these separately. So these are the two methods you can apply. Either you can apply the inbuilt facility, that is the data and data analysis, or you can apply separate equations. So apply your convenience. Now we are going to explain how we can interpret this result in APA format. Now we are going to check how we can present the result in APA format. For that, first of all, you have to draw a table like this. The table 1, then sales figure difference. N equal to 150 means the sample that you have taken, 150 days sales figures. The first column sales, second column N, that means number of observation. M means mean value. The third column is standard deviation. This is the standard error of mean. T is the T statistic. D of degree of freedom, and the p-value. So you have to draft the table like this, only top borders. There is no need of side borders as per APA format. And the title should be in italics. Then table description. Now we are going to interpret the result. An independent sample t-test was conducted within bracket table 1 to compare the sales before and after the advertisement campaign. There is a significant difference in the scores. Within bracket, we have to specify some statistical figures. The first thing is the mean value. You have to put this mean value like M equal to capital M equal to 5871.77. That is this value. Okay. Then you have to specify the standard deviation 339.13. This is the standard deviation, and close the bracket. Then put a semicolon. Thereafter, you have to specify T of 150 observation, T within bracket the observation equal to 23.177. This is a T value. Okay. Then comma, then P equal to 0.00. Normally following 0.00 instead of 0.00, then 0.00. This is the standard reporting style as per APA format. Then these results suggest that there is a significant difference between sales before and after advertisement campaign. So here rejects the null hypothesis. This way you can conclude your interpretation. This is the standard APA format for reporting one sample t-test. This is all about the one sample t-test and its interpretation in APA format. I hope you enjoy this video. You please share this video as much as possible to your friends, and if you are a first visitor to my channel, please subscribe my channel and please comment your opinions and suggestions in the comment section below. Thank you. See you next video.